Here's what you need to know about E. E is a number. It is an irrational number. It stands for something. Can you think of another variable that we use? Exactly, pi. Oh, I thought you said pi. I'm sorry. I misunderstood. Okay, but pi stands for an irrational number. It goes on forever and ever and ever. There's no pattern to the numbers. It just keeps on going forever, right? Can't be expressed as a fraction. It can only be expressed as an irrational number. So E is the same kind of concept. E, and we're not going to get into everything that E stands for. Right now, I just want you to know that it's approximately 2.71, and it goes on forever. What we'll do is we'll use it on our calculator. Okay, there's an E button on your calculator. If you look,
you see my calculator?
No. Why do you always? Okay, if you look on your calculator, I'm assuming you guys have your calculators out now.
What's up, YouTube?
Somewhere around the log or natural log button here on the left, if you hit second and that button, LN, that's the natural log button on this calculator. Different calculators have them different places. But if you have to raise it to a power, raise it to the first so that we can see it. And then you can pull up the E. So we'll be using E on the calculator this way.
Wait,
okay.
Like the letter E? Or
All right, so what we're going to do, we're going to do some operations with E. We're going to treat it just like any other variable. It'll have the same properties. If we have something like 2e to the 5th times e to the 2nd, what would you do there?
2e7.
Add the exponents.
Add the exponents just like we would any other time. Nothing is different here. What if it was e to the 2x times e to the x?
E to the 3.
E to the 3. It's the exact same properties, okay? So I'm not going to elaborate on that too terribly much because I'm going to assume that you remember your exponent properties. Is that a good assumption?
Yeah.
Okay. What I do want to focus on is the graphing, though.
More graphing? Oh. I thought it was just like the first section.
Okay, so this is still growth and decay graphing, and I think when you see it, it'll make sense, or I hope it will anyway. So when we graph with E, this is what it looks like. A times, we're going to have B, actually this is going to be E to the, I don't want to call it B again. Let me call it C.
That's like a
X minus H plus K. Here's why it's different. Now my B, all of this is now what was previously my B, okay? And if you remember, this E is like 2.7, okay? It's going to make sense to you if you just remember that stands for a constant there, okay? So what happens is this C changes, and I want you to really think about that. Max, you need to put that away, please. I want you to really, really think about this for just a minute, okay? How do we have, what's the difference in a growth and a decay equation?
Is like goes up.
Okay, as far as the equation though.
It's
If it has an E, it goes.
No, it's above 1.
Well, if it's above 1.
Bigger than 1. 2.718 is bigger than 1, right?
Indeed.
But I've got this exponent here, okay? Can you think of a way
No.
that, can you think of something I could put in for this C that would cause my entire B to be less than 1?
No.
Anything negative.
Good job, because a negative exponent does what?
Changes it all around.
Flips it over, right? So if I had e to the negative 1, really what I have is 1 over 2.718, da, 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 da. Now I'm less than 1, which means now that I'm decayed. Does that make sense?
How would you do negative 2?
Then it would be 1 over e squared.
Wait, Miss McGee. Oh. So you wouldn't just like square, go like 2.7 or whatever? What?
No, because you'll use it on your calculator so that it's exact.
Okay.
All right, so here's the takeaway from this. If C, because now I'm looking at this C, because my base is 2.718, da 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 da. So now I'm looking at C to determine if it's growth or decay. So if C is positive, it's going to be growth. And if C is negative, it's going to be decay, right? Because that negative exponent is just going to flip it over. Make it less than 1. Does that make sense? Okay, so let me show you a couple examples. As far as the graphing goes, though, it's exactly the same. The only difference is I'm going to have to use my calculator to plug in for E, and I'm going to get some kind of nasty decimals. You're looking at me real funny.
Oh, I didn't hear what you said.
We're going to have to use the calculator to pull up E. Kind of like you would pi. So we'll have decimals. Y'all got it?
Yep.
All right. Let me give you a sample.
I bet there was a thing on soft pie.
We're going to do 2. Let's do...
Remember that thing in Miss Wilson's class that had pi? Like a lot, like
Yeah.
like a million letters of pi, numbers of pi. You have one?
It's not quite as long as hers, I don't think.
Didn't do anything for pi.
No.
All right. So here's what I want to do. I'm going to graph this one just like I graphed yesterday's growth and decay. So before I do, let's just talk about a couple things. Is it growth or is it decay?
Growth.
Growth.
Why?
It's not
But it's
negative.
not negative.
That exponent's positive, right?
Mhm.
Which means this is going to be bigger than 1. Where's my asymptote going to be?
3 or 0.
0.
0, because K is 0. Easy point on the graph.
Is it pretty much the same thing?
It's exactly the same thing.
There's just one more.
Negative. Wait, the easy point would be negative, wouldn't it? Negative.
The easy
0.25?
point H, A plus K.
0.
Yeah.
0,
0.
3.
0. Oh.
Because A is 3. So let's graph it and see what it looks like. Because it's going to look exactly...
Always E there.
B is E to the whatever that exponent is, that very first exponent. All right. Woo.
See, just be like that with me. If you were trying to bug on me for making it terrible.
Oh, Ben.
At least she's not afraid to use the background.
Let me put a grid on here for you.
Yeah. I didn't realize.
Not with
They're
that.
throwing a guy that throws 90. Right? They'll draw straighter lines by, like, without.
Okay.
No, like,
It's not a competition. All right.
Where you hand like a 5-yard
It's
straight line.
like,
Miss McGee, who is
Asymptote's at 0.
who would
Yes?
win in a
Yes.
straight line?
Easy
drawing
point.
like that?
Not me. 0, 3 is what we said. 0, 1, 2, 3. It is growth. If I plug in 1, here's where things change a little bit. If x is 1, that means y is 3 times e to the 0.25. I do not know anybody that can do that in their head, so you need your calculator.
You want to just plug in 3E.
3e, so I do
You're
3
plugging 2.71.
e to the point, no, I want you to use e.
Yeah.
But if we were to 2.71,
It's
we'd be
probably a point or 2 off.
So 3.8.
So about 3.9.
4. Can we just round up 4?
So 1, 3.9,
4.
1, yes, 3. H, A plus K, that's what we talked about before we wrote it. The easy point, H, A plus K.
That's a really subtle bit. Oh, wait, what? Oh, 3.9.
Second easy point, I plugged in 1. I went over 1 to the right. It's the exact same process as yesterday. What's the domain here?
Oh, at negative infinity to positive infinity.
Good word.
What is the range?
0 to positive
Positive
infinity. With no
Would it come
bracket.
off like a test reaction with one bracket?
A point maybe.
Alright, so,
Brackets inclusive, parentheses exclusive. Let's do another one.
how do we know if we're supposed to use brackets or exclamation?
Bro, it's only 8.
Brackets are, guys, brackets are inclusive, parentheses are exclusive.
What does that mean? Can you elaborate?
If it can be that point, you put a bracket. If it cannot be that point, you put a parenthesis. So when we had parabolas, it could be that bottom point. That's why it was a bracket.
Oh.
Asymptotes by definition is what it approaches. All right, y equals e to the negative point. Ooh, do you notice why this one's different already?
Oh, it's a decay.
It is a decay. It's a decay because, why?
It's a negative exponent.
There's a negative exponent, okay?
Terrible.
All right. I want to do my asymptote first, which is 1. Okay. Now I want to do h, a plus k, which would be, no, h is
I can't see the board.
2. What is a? What is k? So what is a plus k?
2.
2. 2.
Miss McGee, you should install like a webcam and have
Wait,
like
what is
the
A?
bottom part of the
How'd you
screen
get
like back.
Because it's a plus k. So a is not there, it's 1. All right, how about easy point number 2? What am I going to use?
Let's use 1.
3. I agree with 3. Always go 1 to the right. It'll make your life easier as you plug in. I get e to the negative 0.75. 3 minus 2 is 1.
Wait, what is
So-
x3 what?
Easy point number 2. I added 1 to where I started. So what is e to the negative 0.75?
E negative 0.75. It is 0.4723665.
0.472. So 3.472, so about a half.
So 0.5.
So 1, 2, 3, about a half. So we had said it was decay. Does this follow? Does it look like decay to you? Yes. Why don't we or why do we? Add the 1 to what? We do. Did I miss that?
I got put 1.47.
Yo, Maya.
Yeah, it's 1.4.
Ramen noodles.
It is.
Yeah.
Oh, that's what I plotted. That's just not what I wrote.
Yeah, it's 1.47.
Yeah, it's 1.47. You're correct. Thank you.
Wait, the one.
I graphed it correctly. I wrote it wrong. What's the domain here?
Negative infinity, positive.
Negative infinity, positive infinity. What's the range?
1 positive infinity.
Bracket or parenthesis?
Wait, seriously, what says it cannot be positive infinity?
Teachers, please pardon this interruption.
You can't
but the
ever
students going
be
to Central
positive
Carolina
infinity.
can report to the